Bhavna. I've had the pleasure of knowing Bhavna and Milind Stawar for many years, and I must applaud them for their dedication to the subject of energy efficiency for almost a decade and a half or even longer. And I would also like to thank the other fellow participants who are participating in this particular webinar. As Bhavna very rightly said, the subject of the webinar is reimagining energy efficiency for corporate India. Purpose and objective of the talk is to underscore the need to reinvent and reimagine energy efficiency in the context of two twin challenges that corporate India faces. The first is the challenge to compete in the global market, and the second is to help address the existential environmental challenge posed by global climate change. I shall do this in the next 40 minutes or so by focusing on four interrelated issues. And these are it's not somehow, it's frozen, it's not somehow, yeah, I got it. This will be the outline of the talk. As they say, unless one knows where one comes from, it will be very difficult to proceed in the right direction forward in the future. So I would talk about energy efficiency evolution and trends in India. It all began. Energy efficiency in the context of current climate change challenges. Based on my discussions on the above two, try to reimagine energy efficiency and define it in the context of three dimensions: a policy dimension, a technology or integrated energy efficiency design approach, then the role of corporate managers and corporate management. Well, energy efficiency trends in India. Energy efficiency began in India way before the energy crisis really began. The program on energy efficiency, the first institutional program on energy efficiency began in something like 1965 or so. And there's a story behind it, and let me share that with you. And it all began with the corporate sector. It was corporate textile industry in Mumbai in the mid 60s were in a little bit of a problem, in a quandary. The supply of coal from Bengal, Bihar was not very reliable because one, there were not many railway wagons available, and two, the railway wagons had to climb the steep gradient of the Western Ghats, and there used to be accidents. So the supply of coal to Mumbai, or Bombay as it was then called, was irregular, not very reliable. And the also coal required large storage space for storage, and space was a premium in Mumbai even in those days. Planning Commission, in a sense, was seized of this problem, but there was another issue which also turned up at the same time. There were two petroleum refineries in Mumbai, in Chembur, both in the private sector at that time, Esso and Burma Shell, and they had excess of fuel oil or furnace oil, which they would like to market. And they thought, why not sell it to the textile industry? Planning Commission, as I said, was seized of this problem and said that, well, what is the problem of using fuel oil in Indian industry? At that time, textile industry and other industries did not have any experience using fuel oil. You know, fuel oil was not used widely in the country. They did not know how to store it, how to handle it, how to prepare it, and how to combust it. So the Planning Commission invited two experts or specialists from the National Institute of Fuel Efficiency Services of the UK. They came by and they set up a fuel efficiency cell in the National Productivity Council of India. And this cell started providing technical services to Indian industry, beginning with the textile industries in Mumbai on oil handling, preparation, and so on and so forth. In 1973, when the oil price hike took place, this cell was able to provide further assistance through oil companies in establishing fuel efficiency studies in the country through the establishment of the Petroleum Conservation Research Association in 1975. And that's how fuel efficiency really took root in the country. And then, sometime in the early 80s, it was expanded to include the concept of energy conservation. You will recall, such of those who were born at that time might recall, that many of the industries, not many, but a few of the industries began to set up energy conservation cells in corporate India. And that was expanded in the 90s to include the concept of energy efficiency, which became more and more mature through energy audits and so on. And now, in 2015 or thereabouts, some of the corporates began to look at energy productivity, and I'll be talking a little bit about that. Today, there is very great interest in energy efficiency as a decarbonization strategy and meeting our net zero goals and objectives and so on. So this history of fuel efficiency to energy conservation to energy efficiency to energy productivity to decarbonization as well as net zero has been a traverse which one needs to kind of understand if one were to look at how one can reimagine efficiency in the years to come. This is a graph which I think is pretty well shown in very many programs, so I will not spend too much of time here. It's developed by the International Energy Association, and the International Energy Agency rather, in Paris. And basically it's a curve developed by IEA on carbon emissions and pathways that can help bend the curve in the next 15 years or so. Red line at the top, the red line at the top is business as usual. Oh, I'm sorry. The red line at the top is business as usual, and you have 5 wedges in different colors. Each wedge represents a technology or a measure. For instance, the blue, light brown, and green wedges represent efficiency in end use and power plants. Green is renewables, purple is biofuels, and so on and so forth. I think the most important point is that if you have to bend the curve and reach the green line down here, which is the 450 ppm scenario or the 2 degrees centigrade scenario, you would have to really depend on carbon emission reduction through efficiency. Efficiency can contribute to almost 45 to 50% of the reduction in carbon emissions, and will be much greater than renewable energy or nuclear or carbon capture and storage and so on and so forth. A similar curve was developed for India, and basically it showed that 35% to 50% of the country's decarbonization targets can be met through energy efficiency. And for the Indian industrial sector, the curve also basically tells you that between now and 2050, energy efficiency can meet up to 41% of our carbon reduction emissions targets. So efficiency is clearly a key factor in our quest for net zero. What are the directions and challenges that we need to look at when we look at efficiency over the next 10, 15 years? So my talk will be covering 4 areas are really three areas of energy management and efficiency that will provide specific directions to corporates who want to embrace the concept of sustainability. These are policy. Number two is technology, basically looking at integrative design approaches which have application in MSME sector, but also in very large scale industrial sector too. And the third is corporate management, embracing energy productivity over energy efficiency, a new way of looking at energy efficiency, what I call moving energy efficiency from the boiler room to the boardroom. So we'll be discussing these concepts in some detail as we proceed forward. I think this at a policy level, it's clear that India needs to balance investments in supply and demand. And this is a cardinal principle that we need to introduce, perhaps through regulatory means, of the need for integrated resource planning, basically looking at both sides of the energy equation, the demand side and the supply side, so that we look at both sides in a symmetrical manner and not sequential. What do I mean by that? Now, historically, since the first five-year plan in India, we have been exclusively supply side oriented. Now, consider that in the 1950s, our total power generation was about 1.5 gigawatts or 1,500 megawatts. And today, after 75 years or so, we are 400 gigawatts. In terms of coal, we mined 25 million tons in the early 50s, and today we are mining approximately 950 million tons a year, and so on and so forth. We have done very well on the supply side, but now we need to look at both sides of the energy equation and put in our resources where we get the maximum bang for our buck. Typically, the cost of conserved energy is through energy efficiency technologies, energy efficiency actions, is 1/5 to 1/10 the cost of an equivalent amount of power generated. If every power utility was required to examine the potential for demand flexibility and demand side management in their service territory, before the decision to set up a generating plant, one can quickly scale the application of energy efficiency in the country. It has its challenges. Anybody will tell you that it's easier to set up a 1,000 megawatt power plant than putting up systems to save 1,000 megawatts from the grid. But it's the principle behind the application of integrated resource planning that would help in reimagining the role of energy efficiency. Take a step back here and look at this graph. It has 4 quadrants. It looks at decarbonization domains or energy efficiency domains which corporate Indian industry can look at. In quadrant 1, you have what is known as the quick hits. I'm not going to spend much time on this. These are first aid measures, housekeeping measures, and every industry, whether small or medium or large, ought to have introduced these no-cost, low-cost measures. The second domain, or second quarter, is must-dos. And these are efficiency measures which have a good return on investment, which are well known, such as waste heat recovery, or whether it's combustion control, efficient motors, and so on and so forth. And Indian industry, especially the large corporate industry, are well seized of the opportunities and basically have been in this particular domain, in this particular quadrant. It's quadrant 3 where, I'm so sorry about it. It's quadrant 3 of integrated designs where Indian industry is beginning to knock on the doors. What is quadrant 3? Quadrant 3 is integrated designs of piping systems, pumping, lighting systems. And we'll talk a little bit more because one can save 20 to 30% more energy beyond what is saved under quadrant 2 in the same system if one were to look at integrated design approaches. It is also looking at chemical process industry, pinch point analysis. It also looks at advanced heat power cycles and so on. So this is the quadrant which I'll be discussing a little bit as to what more can be done at the shop floor to save another 20 to 30% more energy. And that would be a way to reimagine and reconstitute your energy efficiency approach at the shop floor level. And quadrant four is transformational. It is still in the future. I will not be talking too much about it. It's circular economy, digital manufacture, technological innovations such as nanotechnology, and so on and so forth. So it'll be really quadrant three that I will be talking about as far as integrated designs are concerned. It's very important to understand what are the limitations of energy efficiency design as we see it today. Today, we look at energy efficiency in a very separate conventional sense, as a separate entity. So you look at insulation as something separate, or you look at an efficient motor as something separate. And while you can get some savings, you're not able to get and reap additional savings both in capex and opex because you're actually very limited in your scope. What are the limitations of conventional energy efficiency design in industry or elsewhere? Now you have a y-axis where you have the marginal cost of energy efficiency improvement. That is the marginal cost of the energy efficiency per unit of energy saved. Then you have an x-axis where you have the cumulative energy savings, and the curve is the diminishing return. What this means is that you save energy until the marginal cost of energy efficiency improvement is less than the incremental value of the unit energy saved. The marginal cost of investment is greater than the incremental value of the unit energy saved, you stop. You reach what is known as the cost effectiveness limit. And this is what happens with every energy efficiency measure that you implement in industry, because you're looking at it from the narrow sense of that measure only. The question is, and this is the question, can you tunnel through the cost effectiveness limit and save an additional 30 to 40% more energy, correspondingly less carbon? It can be done by a change in approach, by adopting integrative energy efficiency design approaches. Now, what are they? Now, this is the same graph, but now you are tunneled through the cost effectiveness limit, and you are now saving more energy within the same system. What we are doing is tunneling through the cost barrier. Barrier that held us back when we looked at the prohibitive incremental cost of energy savings is no longer a barrier if our approach is integrated. What does this mean? Let me give you an example in industry, a very simple example. How much thermal insulation does one need to reduce heat losses in a pipe? The design approach is to use the thickness of insulating wool, that, or what we call as the minimum economic thickness of wool, that will repay its marginal cost from the percent value of the saved marginal heating energy. But this approach is individually stylized to look at insulation technology only, omits the capital cost of the heating system, omits the capital cost of the boiler, ducts, pipelines, fans, controls, burners, and so on. One can save OPEX and CAPEX if one were to look at the upstream and downstream impacts of insulation and not look at insulation alone. I think that's very, very important. I'll be giving practical examples as we go forward, but the insulation will save you energy, but insulation will also save you capacity of the system, which will save you capital costs and can also save you additional energy because you now run your system at the right capacity rather than operating at a different load. That's important. Another example is the over design of chillers in hotels. See, in a cooling room, The cooling is essentially abstraction of heat from a room. Changes in illumination technology. You have large-scale use of LEDs and so on and so forth, which run cold rather than incandescents or fluorescent tubes which run hot. One, as well as better natural ventilation and so on, and better insulation and so on. One can actually have a smaller chiller than what one would have otherwise, and also a smaller captive power diesel set, because many of the hotels have standby captive power diesel sets. So you have capital savings and energy savings all along the line if one were to follow an approach, not just simply looking at the chiller capacity, but looking at the load that it serves, and the load that it serves, if that load were to reduce because heating load reduces because you no longer use incandescent lamps in rooms and you have better ventilation and so on, you can look at the whole system as a whole rather than looking at it as individual stylized technology. Now, there are barriers to integrative energy design, efficiency design. See, we look at, as I mentioned, and I'm repeating myself, we look at equipments or subsystems in isolation and try to optimize the operations or functions without fully understanding the interaction with one another. The case example of the chiller I mentioned. We try to optimize, for instance, the diameter of a pipe to permit a required flow of liquid without fully taking into consideration the increase or even reduction of dynamic head losses of pump size and performance. And I'll be talking a little bit about this because this is a very interesting case example. Spend a great deal of effort and money on choosing a lighting fixture with the highest lumen efficacy. You'll have a LED of 100 lumens per watt without taking into consideration application or task efficacy. Are we looking into whether the light is reaching the task that is intended to be illuminated? You could have the most efficient lighting system, but if the light is not illuminating the task that needs to be illuminated, then your overall application efficacy is very, very low. So I think you get the drift of what I'm trying to say. And there are some other barriers, but critically, the barrier is not, it's an approach which is important. And there is no technological hurdle to an integrative energy efficiency design. That's the limited point I wanted to make. Several examples of integrated energy efficiency design one can think of at the shop floor level. The first one is big pipes, big pumps, small pipes. You have very small pipes, but the pumps are rather large, and can we have rather big pipes and small pumps? And I'll give a case example on that. Then there's industrial process heat optimization, integrated waste heat utilization, combined heat power generation, water energy nexus, lighting optimization, chiller optimization. I don't have the time to go through all of these, but I will give a case example on big pumps, small pipes, big pipes, small pumps, just to illustrate the principle of integrative energy efficiency design. And then you can take the same concept and look at how that would kind of address issues of process heat optimization and waste heat utilization and so on and so forth. How am I doing on time, Bhavna? Okay, I've got another 15 minutes. Now, it is well known that pumps account for 60 to 70% of electricity used in industry for liquid pumping, for operating compressors, blowers, fans, and so on and so forth. If one looks at pipes and pumps, there are two fundamental equations that govern fluid flow. One is the Darcy equation, and the other is the Darcy. One is the Darcy equation, and the other is the Darcy-Weinbach equation. The Darcy equation basically states that head loss due to flow reduces as pipe diameter increases. The Darcy-Weinberg equation says that friction loss in a pipe falls as the fifth power of the pipe diameter. So if you put both the equations together, what you understand is that pumping costs and auxiliary costs reduce as you increase diameter of the pipe. The only thing that increases cost, that of the pipe itself, that increases in proportion to the square of the diameter or the cross-sectional area. So pumping cost equipment reduces by the fifth power of diameter, and pipe cost increases by only the second power of diameter. When you look at the pipe as a component, the first example I gave of looking at energy efficiency as we look at it traditionally. So when you look at the pipe as a component, which one does in a very conventional design, the size of the pipe is limited by the cost effectiveness limit. You look at the incremental cost of the pipe and compare it with the incremental reduction in head losses and hence the energy savings. Omit the capex savings potential of the pumping equipment. An integrative energy design optimizes the whole system, yielding bigger pipes, smaller pumps, smaller capex, and opex. Changes in design mentality, big pipes, smaller pumps, is the way to go. Corollary to all this is design pipelines first, then choose your pumps. So that's the lesson. Design pipelines first, and then choose the pumps. These are some memorable quotes which kind of illustrate what I've tried to say. Designing a window without the building, which happens all the time. You choose the glass, you choose the size of the window without understanding how the building operates. Designing a light without the room, a motor without the driven equipment is like designing a teacup without a saucer. Optimizing components in isolation is to negatively impact the whole system and hence the bottom line. Can actually make a system less efficient while making each of its parts more efficient simply by not linking up those components. They are not designed to work. When they are not designed to work with one another, they will tend to work against each other. And this memorable quote is by Amory Lovins, who's considered to be the guru of energy efficiency in the US and also internationally. He was the founder of the Rocky Mountain Institute. And I've had the pleasure of meeting Amory several times, and he has been pushing this concept of integrated energy design in the US and believes that one can save 30 to 40% more energy than what a system has been designed for. So if you design a system the conventional way and say that I've saved so much of energy, can you imagine that the same design can save you additional 20 to 30% more if one were to look at the upstream and downstream impacts of the efficiency measure? This was the discussion thus far has been largely on what I would call as the shop floor. But corporate India needs to move energy efficiency from the shop floor to the boiler, from the boiler room rather to the boardroom. And what are the subjects in the boardroom that would kind of attract the attention of the members there? It would be issues related to modernization, value addition, diversification. The question is, what is energy productivity and why is it relevant? How can you empower corporate decision makers in Indian industry to enhance energy productivity? Energy productivity is a measure of the economic value we receive from each unit of energy we use. As simple as that. It is the inverse of energy intensity. Not the same as energy intensity. Energy intensity has a different connotation. Watt hours per ton of product produced is energy intensity. And one looks at energy intensity as a hallmark or a benchmark for industry to follow. And all I'm saying is you flip it and put the energy consumption in the denominator. And on the numerator, you have the value addition or the revenue generated by an organization. And then you look at it, a lot many more opportunities provide itself. It is how is energy productivity calculated? At the national level, it is the total economic output, GDP. At the company level, it is the company's revenue. Divide that by the amount of energy consumed. It's a simple metric, but very, very powerful, as I said. By measuring energy productivity over time, we can determine how effectively any entity, whether it's an industry or a nation or whatever, how it is using the energy it is paying for. What is the value the energy is bringing to the table when you burn it? That's the key point. So corporates in India need to enhance the value their company gets from the use of its energy resources, use of the energy resources that it is paying for. A corollary to this is that corporate management needs to look at ways on reducing energy consumption through energy savings. Reducing energy consumption through energy savings, energy efficiency at the shop floor is well known. I've covered some of it earlier. But approaches to increasing energy productivity through value creation and growth is what is important. And how do we do that is the key point. But first, let's compare energy efficiency and energy productivity so there's no confusion in one's mind. Energy productivity puts energy at the center of economic planning. It's a reasonably new policy narrative that encompasses energy efficiency but is a much broader concept. If you look at these two particular columns, energy efficiency is all about energy savings and growth and profit. Energy efficiency is what I would call a bottom line investment issue. You invest, improve your bottom line, improve your profits. Energy productivity, on the other hand, is a top line investment issue. It creates value and growth. That's why the decision making is at a much higher level and the board level. Energy efficiency is focused on saving energy. Energy productivity is focused on what is the output you're getting out of your factory. From an operational point of view, energy efficiency, you ask the question how energy is used. There's oftentimes the question one asks, managers come by and ask the plant people, how is energy used? And immediately people will say, well, we have to do an energy audit, and they do the energy audit, and the energy audit will identify measures where energy is being wasted and how energy wastage can be reduced through technological measures, through operational measures, through better practices, and so on. This is very, very well known. But if you ask a different question, what is the energy used for? Then it's a strategic question. And is the energy used for creating higher value product, or is the energy used for making a lower value product? Are you making cardboard, or can you make specialty paper? Are you making pozzolano cement, or can you make specialized cement? So increase the revenue for the company, increase its market share by going in for products, and thereby improve energy productivity, rather than just look at measures to save energy at the plant level. There are other aspects of energy productivity and energy efficiency. So energy efficiency is a subset of energy productivity. Energy productivity is a much larger concept. And today, I think when you move energy efficiency from the boiler room to the boardroom, the issues at the boardroom level would be issues related to energy productivity or value creation and growth as to what is the bang you're getting for every unit of energy that you consume. This is the same thing. I'll skip it for lack of time. I don't want to repeat myself, but this is essentially the same point I'm trying to make. Now, how can energy productivity be a framework for corporate strategy? I think that's important, and let me spend a little bit of time here. This shows you a graph about basic energy-intensive products and high-value added industries. Now, corporate India needs to maintain competitiveness through energy efficiency for basic energy-intensive products like mild steel, aluminium, cement, fertilizers, etc. This is known that energy efficiency will improve the bottom line, and one needs to incorporate efficiency measures at the shop floor level. At the same time, corporate India needs to improve energy productivity by developing downstream value-added industries. What does that mean? The questions that corporate India needs to ask is, do we want to make only mild steel? Do we want to go all the way and make alloy steel, which is used in high quality machine tools? Do we want to make just aluminum ingots, or do we want to go all the way and make aluminum for fuselages, which can be used in aircrafts? Do we want to make just cardboard? Do we want to use that energy to make high specialty paper? And so on and so forth. Now, it's not that this is not being done. To a large extent, some of it is being done. But if one were to look at the whole issue through the prism of diversification and modernization, which I think the corporate sector needs to look at, and they will be able to understand that the energy that they are consuming now is yielding value which might not be optimal, and they can yield higher value through a better selection of products and services and goods and so on. And that's the kind of thinking that corporate India needs to bring to bear when they are looking at introducing energy productivity as a strategy. Now, if corporate India were to look at energy productivity as a strategy, then what is the tool that they need to use? Now, on the x-axis, if I might say so, you have diversification to high value added activities, or what I call as the energy productivity strategy and the energy efficiency strategy. You need to do both. And on the horizontal side, you have 5 major strategic elements which I think are important. For each of these strategic elements, for each of these two aspects of energy productivity and energy efficiency, you have 5 major thrust areas or strategic elements. And corporate management needs to engage with banks, investment support for soft loans, FDI facilitation, engage with regulatory agencies for getting regulations changed, such as the integrated resource planning concept, which I mentioned earlier. Needs to have skill enhancement because you need highly skilled people for different products and so on. So skill development, partnership with academia and so on. Then they need to also conduct their own market studies as to what are the kind of new products that they like to bring in, like to manufacture and so on. And then pricing reform. Now, the important point, I think, is that you have to increase value per unit of energy. It cannot be done in isolation. It has to be done in partnerships. It has to be done with having a good understanding of what the market is, what are the skills that you require, what are the policy changes that you like to see, and what kind of investments are required, because these require very major investments in modernization and diversification and so on and so forth. And this kind of provides you with a kind of a toolkit which will enable you to kind of move uh, move along and incorporate energy productivity decision making, enable energy productivity decision making. I've completed almost 42 minutes of my talk, so I'll conclude. Uh, Basically, in conclusion, elements of a future reimagined energy efficiency strategy requires, one is the policy element, which I've mentioned it in, I just mentioned it, and earlier too, I'd shown you that that particular graph of energy supply and demand and why we need to move decision making on the demand side of the energy equation. And if you do that, energy efficiency will be seen as a resource, no different from oil or coal or electricity. It'll be another energy resource. And in fact, that's been the subject of my book, First Fuel. I call the book First Fuel because more energy has been saved than supplied by coal or oil in India and other countries too. No one has tracked it. We think that energy efficiency is only icing on the cake, but actually energy efficiency over a long period of time continuously has saved energy. And if one were to estimate it, it's quite large and can compete with what we have got from oil or coal. And that's why I call energy efficiency as the first fuel. Two is we need to place energy productivity at the center of corporate planning. Uh, any industry which wants to improve its bottom line can do efficiency, but if it wants to improve its top line investments, it can look at energy productivity. And energy productivity is the strategy which subsumes energy efficiency, but it's much more than energy efficiency, as I mentioned. And lastly, at the shop floor level, given the fact that energy efficiency has been around for many, many years, we now need to kind of take the next step and promote integrative energy efficiency designs, which save you more energy in the same system, 20 to 30% more, by looking at the upstream and downstream impacts of the efficiency measure. So thank you very much for your patient listening, and I'll be happy to answer any questions.
Yeah, thank you, Mr. Padmanabhan. So you have introduced a totally new concept, that is integrative energy efficient designs. And I mean, you're definitely, we need to ponder upon it, all the aspects covered in this presentation. So we really need to ponder each and every aspect of this reimagining energy efficiency strategy. Now I open the floor for questions. So let me check. If please, there's one question. Yeah. Mr. Jayesh Thakkar, he is in hotel automation business and would like to have your inputs on energy productivity in hotels.
Energy productivity in hotels. You're talking about hospitality sector, the hotel industry.
Yeah.
Well, the interesting question, because first of all, you need to have an indicator for energy productivity. And in a hotel, I would guess that the output of an hotel is a satisfied customer. And essentially, what does a satisfied customer look for? He looks for value of his stay there. Is it worth the value of paying so much money to stay in a room and get the benefit of the hotel hospitality, the food, the environment, the ambience, and what energy also implies. I don't have a direct answer to him, because one has to really look at how you benchmark a hotel. Unlike an industry, the benchmark of a hotel is very qualitative. But energy productivity can advance qualitative measures as well as quantitative measures. Energy productivity can enhance the environment, can enhance the living conditions in the hotel, and one needs to kind of get a handle on that before one really comes out with any prescription. So I'm not able to come out with a prescription. On energy efficiency in hotels, there are a lot of prescriptions. You know, you can go for green buildings, you can go for well-instrumented hotels with good automation, one can go for better window designs, one can get for high HVAC systems. So on the efficiency front, there are, I would think, a number of well-known practice and lighting going in for LEDs. So this probably is very well known to this gentleman. But going the next step to productivity, then one gets, as I said, into areas related to the value that customers would like to see based on, you know, certain design improvements in the hotel. And it's an interesting question. I don't have a quick answer to it, but I'm sure with his, he can think along the lines I mentioned and see whether there are indicators which he can then employ to benchmark hotels on the energy efficiency side, on the energy productivity side of things.
Yeah. So benchmarking is the key for energy productivity. And now Mr. Sheikh Ali, I'll just allow you to talk so that you can ask your question. Yeah, Mr. Sheikh Ali. Yeah, Mr. Sheikh Ali. Yeah, Mr. Sheikh Ali, can you speak?
We can't hear him, but
Yeah,
we
just
can.
1 second. So if you are not able to connect, so can you just put the question in the question answer box? Till then, I am taking another question. How can we, this is question from Mr. Muthuraman M. His question is, how can we increase the participants of SME in energy efficiency? What type of activities which may attract them to look into this?
Well, the SME sector has been a great challenge. You know, if one were to look at the efficiency journey of India or of other countries too, the large corporates have stepped up to the plate and generally introduced energy efficiency as part of corporate planning. The SME sector, for a variety of reasons, which are well known, have not been able to incorporate energy efficiency to the extent that the potential demands. One is they're non-standardized. Number two is there's this issue of suboptimal size. Number three is the quality of power supply is kind of quite unreliable. Number four is not all of them are bankable and creditworthy institutions, etc., etc., etc. So one knows the problems. But what are the solutions? Now, a lot of attention has been paid of late on how do you deal with SME sector adopting efficiency measures. Particularly, one thing that stands out is in case of SME sector, one cannot theorize. One has to really demonstrate. So if one were to go to a cluster of SMEs, one will have to really have pilot projects and demonstrate exactly how this efficiency measure would be designed, developed, implemented, executed, and monitored and verified. I think that's extremely important. Number two, I think is there has to be funding available from financial institutions who should be willing to take a little more risk in financing efficiency measures in SMEs, either through the ESCO route, which is a distinct possibility. ESCOs can play a huge role in helping SMEs in implementing energy efficiency, but ESCOs would have to be reassured that they would be paid, and that's where some kind of a guarantee financial institutions would be a great help. And there are schemes. I know SIDBI has this program under line of credit from the World Bank for supporting SMEs in energy efficiency and supporting ESCOs to participate and provide assistance to SMEs. Hope that answers the question.
Yeah. So we are still not able to connect with Mr. Ali, and he has not put his question also. Any other questions? You may raise your hand so that I can allow you to speak also. Yeah. There's one question from Mr. Nageshwar KH. So, is energy efficiency really matters in reducing global warming? Earth is receiving energy from sun every day from millions of years and in future too. So, as we know, energy is neither created or not be destroyed. So, where would that energy go?
Very interesting question. First part of it is, can energy efficiency reduce or mitigate global warming? The thing is very clear that human beings are, and their actions are actually contributing to global warming. The connection between Homo sapiens and their actions and global warming is now abundantly clear. No one is disputing that. The way the human beings are impacting the climate is through the emission of carbon. And the emission of carbon is largely due to the burning of fossil fuels. And efficiency, to the extent that you can reduce the consumption of fossil fuels, will reduce carbon emissions, and to that extent, reduce the impact of carbon in the environment, and start beginning to impact positively the rise in global temperatures. So efficiency has a role, a very important role to play. And as I showed in my earlier graphs, that 40 to 45% of the decarbonization potential in India can be met through efficiency. So efficiency is not just a also ran kind of an energy resource. It's probably the most important energy resource. And I call energy efficiency as energy resource because energy conserved is energy generated. And there's no difference between efficiency and coal or oil. While coal and oil provide you energy through combustion, efficiency provides you with the need not to use additional energy through conservation. And that has more impact on the environment because you don't emit any carbon while reaping the benefits of energy savings. So that is the first thing. The other question was on renewables and solar. And certainly, one would like to see the energy transition finally moving from a world dominated by oil and coal to a world dominated by renewables. And that's the challenge. If you really look at the whole thing, very simply said, we are today in a world dominated by oil and coal, and we need to move to a world dominated by renewables, essentially solar and wind and biomass. Efficiency can be the bridge because you need a foundation, a foundational strategy. Now, for instance, to give you a simple example, to have a photovoltaic system, solar PV system, and the power is used, generated by that is used to, let us say, power a lamp. And the lamp is, let us say, an inefficient incandescent lamp. So imagine spending a fair amount of money, capital money, to set up the solar PV system. And then 80% of the electricity generated through solar PV is wasted because an incandescent lamp is hardly 8 to 10, 1 to 2% efficient. So more than 80% is wasted. You would like to have a more efficient lamp, such as an LED. And if you have an LED, then the size of the solar system also can be reduced. So efficiency has to be an intrinsic part of any renewable energy program or project. And if it is, and actually there are two sides of the same coin. So I don't want to belabor the point. You need renewables, but to move to renewables, you need efficiency as the vehicle. Hope I answered the question.
Yes, that was a nice answer. I mean, I hope the query is clear now. And we have next question from Mr. Dilesh Bhatt. Yeah, Mr. Dilesh, you can put forward your question. Yes, Mr. Dilesh.
Good evening. Am I audible?
Yes, you
Yes,
are audible.
you are, sir.
Yeah. First of all, Mr. Padu, thank you so much for the wonderful book on first fuel. It's an amazing read for energy professionals like me. And my question is pertaining to the ESCOs. In India, we try to find out many ESCOs in certain proven energy efficiency technologies, but we aren't able to find them. So in spite of having the energy efficiency technology in place, we are not able to implement it due to lack of funds, mainly diverting to maybe for capacity enhancement or maybe product enhancement, but not really for energy efficiency. So in that case, do you foresee, ESCOs gaining more popularity in India as they are doing well, maybe in Middle East or maybe in the States or maybe in Canada? So do you foresee ESCOs doing well in the near future in India?
It's a very good question. And actually, as you said, the promise of ESCOs have not been fulfilled in India. There are a variety of reasons for that. One may be that corporate India was a little late in taking on the concept of ESCOs. Remember that ESCOs, when they enter a factory or an entity, they would have to have the full play of that entity. They would be responsible not only for the investment of the particular technology, but also in many cases have to be involved in the implementation and in the operation. Because finally the ESCO will be paid through the savings in energy, and the savings in energy means that the right operational practices will have to be followed. Maybe that concept, at least in Indian industry, did not catch on. But there are certain sectors of industry. When I say industry, I use the word very loosely, like hotel industry, hospitality sector, like in offices and so on, where ESCOs could play a role. And indeed, there have been some cases in the building sector where ESCOs have played a role. To answer your question, yes, I do see a role for ESCOs in some sectors, not in all. And as time progresses and with more experience, then I think the ESCOs will start making an important contribution. Now, having said all this, a key point is most of the ESCOs are underfunded, they're very small, they don't have the financial resources. So financial institutions will have to step up to the plate and will have to open a window, a financing window for ESCOs, so that the ESCOs can use those funds to make to invest in the measures which then could give the savings on which their bottom line actually has relevance too. So it's a chicken and egg kind of a situation. You don't have the money, then you can't get the project. You don't have the project, you'll not get the savings. You don't have the savings, you'll not be able to pay for the ESCO and its services. The ESCOs play a huge role because they cover some of the operational risks which are there, because industry might be reluctant to invest, as you rightly said. They may invest in product creation, expansion, but not in energy efficiency because they're not too sure whether that will yield the kind of savings. When an ESCO comes in, one thing is very clear, that the ESCO will monitor energy use very, very closely, will really track energy use. And that information, I think, is extremely important for industry to have, because in many, many cases, industry simply does not have the wherewithal to track, measure, and verify what is the energy which is used and how much is actually. And ESCO will at least bridge that particular gap. So I'm not sure whether I've answered your question. I think there are certain sectors that will move forward fast. Other sectors, it may take its own time. But it's a huge change, let me tell you, from the time when ESCOs were first thought of in India in the 70s. And actually, I was there at that program. And we had heard about ESCOs at that time from literature about how ESCOs operate in the United States and in UK, and we talked about it. But at that time, there was a kind of a barrier because energy efficiency was considered to be a humanitarian task. It was based on altruism. One should save energy for the nation, and one did not actually look at efficiency from a business perspective, which today it is. I mean, ESCOs will look at it from a business perspective, but when I'm talking about the license large days, the days of the 70s and early 80s, when efficiency was considered to be a patriotic duty based on altruism and so on. And when the subject of ESCOs came up, the first reaction from some key officials was, no, 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 it's not for India, you can't make money out of this and so on. That was the mindset of the past. So we have passed all of that. That's the point I'm trying to make. And today ESCOs have a place in the scheme of things, but they're not growing as fast as, for instance, in China and other countries where ESCOs have really blossomed.
So much, sir, for your insights.
Thank you.
Thank you, sir. Mr. Sheikh Ali, can you speak now?
Vamna, can you hear me?
I can hear you, Mr.
Thank you, Vamna. Mr. Padmanabhan, thank you very much for throwing a light on a different dimension. I think it is well conceived and well narrated. Thank you very much for that. I'm sure everybody will get benefited. Now, my question is related to the 4-quadrant approach that you talked about, and particularly the first quadrant, where you said the low cost and no cost. My question is related to that, but then I need to give you the narrative of my question so that you understand clearly what I intend to say. So you have to allow me about 30 seconds so that
Sure.
I give the narrative correctly. When we talk about the policy, I think every government, not only Indian government, every government, they need to realign their policy with the ground realities. That is one part. Second part, when you're talking about the corporate, I think corporates need to walk the talk. Now, let me give you an example for both. The energy management, energy efficiency, energy crisis, every government is tackling since last 50 years, and still it is not sustainable. And that is the reason I said they need to realign at the ground level. It is evident. I don't want to deliberate much on that. The second part, when you talk about the management, they need to walk the talk. What I mean to say is that they need to change their mindset. One hand, they talk about energy efficiency and energy conservation. Another hand, they still want to stick to L1 concept of purchasing. They don't want to see it as an investment, but then they still continue to see it as an expenditure. Now, coming to your first quadrant, I think it is quite obvious, easily available, and knowingly or unknowingly, it goes out of our radar when we need to approach. And to give you an example, I would like to cite the example of what happened at 8 o'clock on 5th of April 2020. On that 20 minutes, you spoke a lot about lighting, lighting, lighting. Lights were switched off, not even 100% houses. And in that 30 minutes, the drop in national grid was 31,089 megawatt. It gives a clear indication that the human intervention, behavioral changes, the administrative corrective actions has the potential even to offset the morning and evening peak in any countries, thereby saving millions of rupees and saving so much of fossil fuel, particularly when you talk at the backdrop of world known fossil fuel reserve and carbon space availability, because there we are against the wall. So I would like to hear your point of view from these two background. Thank you.
Well, that's a very long question, but I think I have a sense as to where you are coming from. The first quadrant, as I said, what I call as quick hits, are low cost, no cost measures, housekeeping measures, and so on. Actually, hidden behind that is a concept which you alluded to at the end, which I think is extremely important. That is to do without. It is not as though energy efficiency means that you save energy, but also means that you can obviate the necessity of using that very energy. You know, to a large extent, and I think India's contribution to the efficiency program globally could be not only in terms of technology, but also in terms of practices and lifestyle choices, where one consumes less. In many ways, one even does with no energy and yet has a decent standard of living. I think that's extremely important. And the Honorable Prime Minister's LIFE program, where he talks about lifestyle choices in the use of energy, I think is extremely important and has to be a key part of any national strategy on energy efficiency. Now, talk about a corporate sector. This is, individual choices, but individual choices actually amount to a number, when they all pool together. And if individual choices are to do without energy, without affecting the lifestyle, that's the important point, without affecting your lifestyle. That is the other point that you did mention, and I totally empathize with the other points that you make, that efficiency has not really caught the attention of governments, corporate management. We have been doing it for the last 50 years and so on. And one of the reasons, not only reason, one of the reasons could well be that we have not institutionally positioned energy efficiency in our government decision-making machinery properly. Now, and this is no, what should I say, criticism of what the bureaucracy is doing. It's just a commentary on the bureaucracy. Now, you can't have an efficiency program run in a ministry which is totally devoted to energy supply. See, as I mentioned or alluded to in one of my earlier graphs, that efficiency and supply are two sides of the energy equation. And if you have a ministry which is totally dedicated to power generation or coal production or oil prospecting and all that, and then you have an efficiency cell or efficiency department there, then it'll have to compete for attention and is not going to get the attention it deserves. I always say that, I mean, more of a tongue in the cheek statement, that if I, along with the chairman of a national utility, were to wait outside the Secretary Energy's room and I have a card which says I'm an ESCO and he has a card which says that he's head of a utility, who will the secretary call into the room first? Obviously, he'll call the person on the supply side first because they represent growth, they represent capacity, they represent investments. Now, that's the mindset that we have to live with, but we need to move out of that and look at efficiency and reposition efficiency outside the supply ministry. And how do we do that? Well, Philippines has done that. Thailand has done that. They have got efficiency offices which report directly to the Prime Minister. That's something that we can work on. So, and that's something for the bureaucracy to kind of look at. And I've written some notes on this particular issue. So that's also part of the way in which you can raise the profile of efficiency. I hope I've answered your question, because your question was more in the context of observations, and I'm totally with you on your observations. And I'm just trying to illuminate some of the points that you made with some examples.
Thank you. I just wanted to have your perspective. Thank you.
Hope it helped.
Thank you. Yeah. I hope, Mr. Padmanabhan, you will not mind taking one more last question.
Oh, no, I don't mind at all.
Yeah, because people are having questions. So just one sec. Mr. Ashish Tikhe. Yes, Mr. Ashish.
Am I audible?
Yes, you are audible.
Good afternoon, Mr. Padu. Thank you for your great webinar. So we are basically project developers and investors in on-site sustainable energy projects. I'm basically from BCIs, Berkeley Energy Commercial Industrial Solutions. So we have a lot of on-site solar projects and biomass-based steam projects where we have invested ourselves in this project, and we are selling steam or renewable energy to the customer. And we are also working on developing energy efficiency business for large industrial and commercial sectors. So would like to have your opinion, which sectors and which technologies do you think are low-hanging fruits for such investments in today's date?
Well, I wish I had a magic wand and tell you exactly where one should invest in, but I think providing technical inputs to industry to save energy through energy audits and so on are fine, but we probably have reached some kind of a impasse there. The reason I mention that is that energy audits, for instance, is not a destination, it's only a way station. An energy audit will tell you how much energy is being consumed in a particular process, where the opportunities lie. You have to go the next step of actually saving energy. Because the thing about energy efficiency is it cannot be metered. It can only be measured. You need a before and an after. There's no meter in the world which will tell you that you have saved so much of energy. But what the meter will say is this is what you consumed earlier, this is what you consume now, one minus the other is what you saved. And for that, you need a system, you need a measurement and verification system. And Indian industry hasn't, by and large, developed MNV systems. I see a great opportunity in that service, the MNV service. The service of energy auditors was there in the 70s, 80s, 90s, and continues to be there, and I wish it all the well. But in and by itself one must recognize that energy audit is only an instrument, it's only a way station, it's not the destination. And M&B is the destination. So there's a great deal of opportunity there. Away from that, you had mentioned that you are now supplying steam to some industries, etc. I think that's a good idea, that if one can look at a cluster of industries and provide them with energy services, whether it's cooling or heating or steam or compressed air and so on. That could be an interesting service one can provide to a cluster of small and medium scale industries. The issue of management of that is extremely important. And then there are individual technologies. I mean, there are no limits to the list of technologies one can get into. And basically the principle is that any process can be improved upon. Either improved upon by better operational practices or improved upon by better technologies. And one needs to kind of, then decide what you want to really do. So just to sum up, and this is really off the cuff statement, I think M&B would be an area which you might like to look at, and providing utility services to a cluster of industries could be another area. I hope that helps.
Yeah.
Yeah.
Thank you, Mr. Padmanabhan. So, question answers session was equally interesting as your presentation, and it is very good that so many people could remain. In this.
I would like you to, because in a webinar one can only do this much, just react on the spur of the moment to a question. But then later when one reflects over it, one could probably add another element or two more to it. But
Yes.
If any of the participants are interested, they can send me an email and I'll be happy.
Yes, definitely.
Get back to them. I have given my mobile number as well as my email, and be in touch and give them a little information.
Those mobile number and email address is already on screen, so everyone can do that and ask any questions if any.
And also, not a plug. There's not a plug for my book, but if they have the time to read my book, First Fuel, it's available on Amazon. You just type First Fuel and Padmanabhan and you'll get it. And that kind of gives you, I think, the history of efficiency written in a narrative form. It's written exactly the way I speak. There are no tables, there are no charts, there are no equations. And the case studies are only focused on narratives of what worked and what didn't work. So I think it's easily readable.
Yeah. So thank you so much once again. And for attendees, I would like to tell those interested in membership. So from next month onwards, membership fees have been reduced to $40 by AEE. And so if you are interested, you can reach us on the email address or mobile number as given in the mails and also in this chat. So thank you so much. You all be a wonderful audience and wonderful listeners. So, and thank you, Mr. Padu, once again for such a illustrative presentation, and hope many will benefit out of it. Thank you.
Thank you. Thank you, Bhavani. Thank you. Thank you, everybody, for your lovely questions. Okay, bye.